In this video, we're going to go over the many steps it takes to turn rough sawn lumber into a finished product. This is rough sawn white oak. Rough sawn wood is typically warped, twisted, or bowed. It does not have straight edges or flat surfaces, as you can see in these two boards, which have a twist. The reason for this, when lumber is first sawn, it is typically green, which means it has a very high moisture content. As the lumber dry, it usually tends to warp. The first step in milling lumber is to use a jointer. As you see the wood pass through the jointer, it opens the guard, exposing the revolving blade below. This blade removes all the high spots from the board as it passes over. You run it through as many times necessary until the bottom of the board is completely flat. Once doing so, you place that flat edge against the fence. Run it through, surfacing the edge. What this does is creates two finished surfaces that are exactly 90 degrees one another. The next step is to go to the table saw. First, you must set up the table saw according to the lumber you're cutting. So you raise the blade to the height you want and then designate the width that you want. This table saw has stock guides that are attached to the fence. Stock guides can be adjusted to whatever thickness lumber you have, which holds it down to the table as you are ripping. In addition, the rubber wheels on it are in a slight 5-degree angles that point towards the fence. So what this does, as you're pushing it through, it holds the material tight against the fence as well, which helps prevent kickback. Next, we will go to the bandsaw to do some resawing. Right now this material is roughly 1 3/8 inches thick. The finished product only needs to be about 1/2 inch thick, so I'm resawing this lumber down to 5/8 of an inch. After resawing our boards, we will go to the thickness planer next. Typically, a thickness planer can mill lumber anywhere between 8 inches and 1/4 of an inch. Since our boards are resawn at 5/8 of an inch, I will set up the planer just under 5/8 of an inch. If you remember, all these boards have one surface that have been milled on the jointer. Those surfaces need to face down for the first run, since the revolving blade will take material off the top of the boards. After all the boards have made a pass through, you then adjust the table up a little higher to take off more until you reach the desired thickness. In this case, that thickness is 1/2 of an inch. After we have finished planing our boards, we will go to the router table. A router table is designed to put profiles on the edge of wood. There are hundreds of different types of router bits that put different profiles depending on what you desire. As you may notice, this router bit has a bearing on top. Bearings are designed to keep the router bit from digging too far into the wood. When using it on a router table, you line up the bearing with the fence. This router table also has stock guides, which helps hold the material down to the table and tie it against the fence. For this application, we are using an 1/8 inch radius roundover bit. Since this material are the slats for the bottom shelf of the table, we will be putting a roundover on all 4 edges of the board, as you can see here. This table has 2 stretcher boards that holds the slats we just finished milling. In order for these stretcher boards to house the slats that we made, we'll have to cut a dado along the entire length of the stretcher. To perform this operation, we will remove the blade from the table saw as well as the riving knife and install a dado blade. Most dado blade sets can cut a dado from anywhere between 1/4 of an inch to 13/16 of an inch. It all depends on how many of the blades you put on. In our case, we have to have a 1/2 inch wide dado. And as you can see, I've checked with the digital caliper to make sure the blades are as wide as I need. It is always a good practice to run a test cut first. That way you can check to make sure the dado is exactly where you want to put it in your finished board. At this stage, you do not want to make a mistake on your finished boards. Now we have a perfectly cut dado all the way down the entire length of our stretcher to hold our slats. This is a Craig pocket hole jig. We will be attaching our stretchers to our legs of our table using pocket hole screws. This jig allows us to drill holes for those screws. As you will notice, this jig has different patterns for holes. In our case, we're going to use holes A and C because they line up correctly with our boards that we're going to be drilling. The first step is to clamp the board into the jig, spaced evenly so that the holes are lined up correctly. Now that we have our stretchers ready for assembly, we will line them up exactly how they go on the legs so that we can measure how long the slats are. They measure 11 1/8. Next, you will see I've set up a stop block on the miter saw at 11 inches. So I mark my board at 11 inches and check to make sure my stop block is in the right place, which it is. Now I can cut multiple slats at 11 inches without having to remeasure each time. Now is an example of why math and understanding fractions is so important in woodworking. If you remember when we first ripped down the boards, I set the table saw fence to a desired width. I knew that my rips were going to be somewhere around 2 3/4. I already knew that my stretchers were 26 1/8, so I divided 26 1/8 by 2 3/4 and came up with 9.5. I rounded that up to 10 because I would have to have 10 slats. I then took 26 1/8 and divided that by 10, which gave me 2 5/8 of an inch, which is what I cut my slats. As you can see, with all my slats together, they measure 26 1/8, just like the stretchers. We have finished cutting all the boards for our table, and the next step is sanding. As you'll notice, I took a pencil and scribbled a line down the entire surface of this board. This is a good practice to have when you are sanding, because once the pencil line is gone, you know you have sufficiently sanded that edge of the board, and you move on to the next. Sanding can be a very daunting task that can be one of the most mundane parts of woodworking, but there's always ways to make it easier. Here is one example of making sanding easier. Before assembling the table, I am sanding all the pieces first. This is not necessary, but it does make it much easier than after assembly because you have nooks and crannies that you have to fight with that you can't get the sander to. So by sanding now, I can access all the edges of my boards without complications. Next, I'm going to work on preparing the tabletop. As you can see, this tabletop has some discrepancies in it. It has some natural growth cracks that can be easily repaired instead of discarding the wood. To do this, I'm going to use a two-part epoxy from West System. This is the epoxy resin, which is part 1, and then part 2 is the hardener. As you can see, it is a slow hardener to give me more working time. I will also be adding a tint to the epoxy to match the color of the wood. In this West System, it comes with plungers that automatically measure the amount of epoxy and hardener used to mix together. As you'll notice, I'm just adding 1 drop of tint because this tint goes a long way. Once I have adequately mixed all the epoxy and tint together, I will start applying it to the discrepancies in the board. As I apply this epoxy to the board, it will slowly seep down in the cracks and holes and start filling them in. Not only does this strengthen the board, but it also acts as a wood filler that can be sanded down later, after it dries. And since I used a slow hardener, it will take approximately 24 hours for this epoxy to dry completely. Once the epoxy has fully dried, I can then sand it. For this, I'm using a 6-inch random orbital sander with 80 grit sandpaper. Epoxy is very hard, so it takes a lot of rough sanding to get it worked down. The last area of epoxy is very thick, so I'm going to use a glue scraper to work down the epoxy first before sanding it to save me some work. As you can see, the edge is very sharp and it will slowly grind down the epoxy layer by layer. Now that I have removed a significant amount of the epoxy using the glue scraper, I can finish my sanding. Once I have finished my first rough sanding, I will switch to a 180 grit sandpaper to do my finish sanding. Now it is time to do a pre-finish, which is the first coat of finish. As you can see, I'm using a satin varnish called Armor Seal. This can be applied to the wood using just a rag instead of a brush, which makes it much easier. Just like with sanding, it is a good idea to put your first coat of finish on before assembly because some areas will be difficult to get to once the table is assembled. I will also put a coat on the legs and the apron of the table. The next step is assembly, so I'll lay a stretcher down on the table and start sticking the slats down in the dados that were created. Once all the slats are in, I will then put my next stretcher on. In order for all these pieces to stay in place while I'm attaching the table, I'm going to use some parallel clamps to hold them together. Once I have the lower assembly in place in the table where I want it, I will add more parallel clamps to clamp the legs tight against the stretcher. To attach the stretchers to the table, I'll be using 2-inch pocket hole screws. These screws will go into the pocket holes we drilled earlier. Since pocket hole screws are put in at such a steep angle, you must use a long bit to achieve this angle. Once all the pocket screws have been put in their holes, I can then remove the clamps from the assembly. Next, I will be attaching the top to the apron. This apron has an 1/8 inch by a 1/2 inch groove cut all along the edges. In a moment, you will see why that groove is there. Next, we will put the tabletop topside down on a piece of cardboard to protect it, and then we will put the assembly on top of the tabletop. To attach the assembly to the tabletop, we'll be using these clips. These clips fit into the grooves that are cut into the apron. The reason we do this is because wood expands and contracts. The tabletop will expand and contract over time. If we were to permanently attach the tabletop to the apron, it would eventually cause damage to either the tabletop or the apron through cracking or warping. These clips allow the tabletop to move freely as it expands and contracts. As I put screws into these clips, it cinches the apron tight against the tabletop, closing all gaps. Now, the table is completely assembled. And notice, the top is firmly in place. Now it is time to put the final finish coat of varnish on the entire table. Once the varnish has completely dried, we can start the finishing touches. Using 4/0 steel wool, I will start to rub down the entire surface of the table. What this does is removes any rough spots in the varnish where dust or something else might have settled while drying process. It also creates a nice sheen in the varnish. And finally, I will add some felt pads to the bottom of the table legs. These pads help protect the flooring surface as well as the bottom of the table legs themselves. These pads are just peel and stick. And that completes the white oak printer table. I hope you have enjoyed this video. Please subscribe.